I'm with Fernando Nuño from the European Copper Institute. Thank you for being here today.
Hello, thank you.
It's nice to have you. It's nice to have a presentation of the motivation of the European Copper Institute for energy efficiency in motors. My first question would be, copper is in all things that use energy. Why is it such an important material?
Well, copper is important for energy because it's the material with the highest thermal and electrical conductivity, apart from silver, which is not an affordable material, while copper is abundant and available all over the world. It's also a ductile and resistant to corrosion material, which makes it suitable for durable and reliable connections on joints. It's also easy to alloy, so you can obtain interesting combinations of properties, such as high conductivity together with high mechanical strength or any other property. And finally, it's highly recyclable, not only on technical basis, but also on economic basis.
Is there sufficient copper to drive the energy transition?
We have at Copper Institute carried out an exercise to estimate what could be the net demand for a 100% renewable system by 2050. We came to the conclusion that 20 million tons additional were needed for making it happen. While significant, this is spread over 35 years, which means an average increase of 14% per year, 1/4, which is likely feasible. How much copper is available out there? The annual mining production, so primary copper, is 18 million tons per year, but reserves are much bigger. They represent about 40 years of equivalent production, so 720 million tons. If we go further, resources, which are unexploited copper deposits identified through geosurveys, these are far larger. These are as much as 5,000 million tons, which represent almost 300 years of exploitation. So this is one part of the picture. The other part of the picture is recycling. So copper is highly recyclable. It can be recycled repeatedly without any loss of performance. And actually, European Union sources 50% of its copper through recycling. So with both avenues together, there is surely sufficient copper to drive the energy transition.
So an efficient motor needs more copper.
Mm-hmm.
Is this sustainable?
When it comes to sustainability, the life cycle perspective should prevail. It's to be considered the fact that motors, the biggest impact for motors takes place in the use phase. So any energy efficiency gain pays off largely. To take an example, a 22 kilowatt motor could be increased an efficiency level by adding just 1 kilogram more of copper. It consumes or it takes 3 more kilograms CO2 in its production, but it saves 3,000 kilograms CO2, so a ratio of 1 to 1,000. So we can see clearly how, from the CO2 perspective, is largely sustainable. From a material use perspective, even if we are using more copper in the manufacturing phase, it's fully available at the end of life for recycling and reusing it again without any loss of property. So it's not, in the end, natural resource consumption, it's just you postponing the use.
The International Copper Association has supported energy efficiency in motors for more than a decade. Why is that so?
In order to make the energy transition happen, we need to move from conventional generation to renewable generation. We need to move from internal combustion engines to electrical drives, and we need to implement a lot of energy efficiency. So, International Copper Association is not only supporting energy efficiency in motors, but in other areas where the energy transition is required, such as mentioned: electric vehicles, renewables, energy efficiency in buildings, etc.
Do permanent magnet and synchronous reluctance motor also use plenty of energy, or are they a technological competitor for you?
Permanent magnet and synchronous reluctance motors use copper as well, though in lower amounts than induction motors. However, these are not seen as competitors, but rather as a part of the solution to make the challenges of energy transition happen. For instance, to illustrate this, the European Copper Institute has promoted a project which is named ReFreeDrive, and it's about developing motors without any use of rare earths. And here we are partnering with induction motors and synchronous reluctance to achieve high performance for electric vehicles.